A lamp rated 230 volts emits a light of 1000 lumens. Okay, the mean spherical candle power MSCP. Okay, we have to find MSCP, mean spherical candle power. Okay, mean spherical candle power is equal to luminous flux by 4 pi. Luminous flux by 4 pi. Okay, luminous flux is 1000 by 4 pi. Okay, we will get around 79.69. okay, approximately 80. Okay, from the options, option A is the correct answer. Okay, MSCP is equal to luminous flux by 4 pi. Okay, next question. The unit of solid angle. Okay, solid angle of units enti radian, steradian, degree. Okay, solid angle, we have two angles. One is plane angle, this is plane angle. Plane angle, angle between two planes is plane angle. Okay, manaku solid angle vachesi 3D object. Okay, any 3D object, this is cone, this angle is solid angle. Solid angle. Okay, this is solid angle and this is plane angle. Okay, plane angle units vachesi radians. Radians. Alage solid angle units vachesi steradians. Steradians. Okay, solid angle angles are steradians. Option B is the correct answer. Okay, next question. The solid angle suspended by sphere. Okay, the solid angle suspended by sphere is, okay, pi steradians, 2 pi, 3 pi, 4 pi. Okay, solid angle is equal to area by radius square. Area by radius square. Okay, area by radius square. What is the area of sphere? The sphere area is 4 pi r square. R is the radius of sphere. Alage radius square, r square. Okay, r square and r square will cancel. Okay, we will get 4 pi. 4 pi is the solid angle of sphere. Okay, from the options, option D is the correct answer. Okay, next question. The amount of current flowing through the resistors depend on. Okay, amount of current will depend on applied voltage only or ohmic value of resistance, both applied voltage and ohmic value of resistance. Okay, we have Ohm's law. Ohm's law. What is Ohm's law? V is equal to I R. Okay, this is current flowing through the resistor. Okay, I is equal to V by R. Okay, I is directly proportional to voltage applied and I is inversely proportional to resistance. Okay, okay, I depends on voltage and resistance. Okay, from the options, option C is the correct answer. Okay, the amount of current will depends on applied voltage and ohmic value of the resistance. Okay, next question. In the circuit Vs is, okay, we have to find this Vs value. Okay, I will read out the circuit. This is 2 ohm resistance and this is 4 ohm resistance. 2 ohm and 4 ohm are connected in series. The combination is connected across the voltage source Vs. Vs. Okay. Now the voltage across 4 ohms resistance is 8 volts. 8 volts. Okay. Now we have to find current through this circuit. Okay. Here 8 volts is across 4 ohms. Now here current I is equal to V by R. Okay, 8 by 4. 8 by 4 is equal to 2 amperes. Same 2 amperes current will flow in through 2 ohms also. Okay, 2 amperes current will flow. Okay, now apply KVL in this loop. Okay, apply KVL. KVL minus Vs. Okay, plus 2 into 2. Okay, plus 8 volts. Okay, 8 volts is equal to 0. Vs is equal to 4 plus 8 is equal to 12 volts. 12 volts. Okay, from the options, option C is the correct answer. Okay, next question. The total capacitance between P and Q is, okay, P and Q. This is Q, this is P. Here 1 farad, 2 farads. Here 6 farad. Here 1 farad and 1 farad. Okay. These two capacitors are connected in parallel. Means 1 plus 2. 1 plus 2 is equal to 3 farad. Okay. Again these two capacitors are connected in parallel. Then 1 plus 1 is equal to 2 farad. Okay. This 3 farad, 6 farads and 2 farads are connected in series. 3 farad, 6 farad and 2 farads are connected in series. Connected in series. Okay. Now 1 by C equivalent is equal to 1 by 3 plus 1 by 6 plus 1 by 2. We will get LCM is 6. 2 plus 1 plus 3 is equal to 6 by 6 is equal to 1. Okay. C equivalent is equal to 1 by 1. C equivalent is equal to 1 farad. Okay. From the options, option B is the correct answer. Okay. Next question. The value of inductance needed to store 4 kilowatt hour energy in a coil of current carrying 2000 amperes current is, okay. Here energy E value is given. E is equal to 4 kilowatt hour. 4 kilowatt hour is equal to 4000 watt hours. Okay. We can also write 4000 into 3600 watt second. Okay. We have to convert this watts into hours. Okay. Now we will get 4 into 36 into 10 power 5 joules. Okay. 10 power 5 joules. This is energy. Okay. Now current is there. Okay. We have energy formula. Energy stored in inductor is equal to 1 by 2 L I square. Okay. Energy is 4 into 36 into 10 power 5. Okay. Is equal to 1 by 2. We have to find L value. I square is equal to 2000 into 2000. Okay. This 5 zeros and 10 power 5 will cancel. Okay. Now 20 will remains 2 1 ja 2 10 ja. Okay. Next 4 into 36. Now L is equal to 4 into 36 by 10 into 20. 10 into 220. Okay. 20 is equal to 144 by 20 is equal to 7.2 Henry. 7.2 Henry. Okay. From the options, option B is the correct answer. Okay. Next question. What does the below symbol indicates? Okay. This symbol indicates what? Transformer, capacitor, resistance or inductor. Okay. This is the symbol for inductor. Alage this is the symbol for capacitor. Okay. Alage this is the symbol for resistor. Okay. Here inductance symbol is given. From the options, option D is the correct answer. Okay. Next question. Which condition is the correct for resonance condition? Okay. Resonance condition. Okay. Resonance condition la manaki inductive reactance is equal to capacitive reactance. Okay. Under resonance condition. Under resonance condition. Under resonance condition, inductive reactance. Inductive reactance is equal to capacitive reactance. Capacitive reactance. Capacitive reactance. Inductive reactance is equal to XL is equal to XC. Okay. From the options, option D is the correct answer. Okay. Next question. The reciprocal of frequency is known as, okay, the reciprocal of frequency, amplitude, time period, time constant or resonance. Okay. Time period. Time period is equal to 1 by frequency. 1 by frequency. Alage frequency is equal to 1 by time period. Time period. Okay. The time period is the reciprocal of frequency. Alage frequency is the reciprocal of time period. Okay. From the options, option B is the correct answer. Okay. Next question. If 1000 watt heater is used for 5 hours, then cost of energy at rate of 1.5 units per 1.5 rupees per unit. Okay, we have to find total cost we have to find. Okay, now energy is equal to power into time. Okay, power is 1000 watts into time is 5 hours. Okay, we will get 5000 watt hour. 5000 watt hour means 5 units. Okay, 1 unit is equal to 1000 watt hour. Okay, 1 unit is equal to 1000 watt hour. Okay, 5000 watt hours means 5 units. Okay, per unit cost is 1.5. Okay, per unit cost is 1.5. Here 5 units. Okay, cost is equal to units, number of units into per unit cost per unit. Okay, number of units is 5, cost per unit is 1.5. we will get 7.5 rupees. Okay, total cost is 7.5 rupees. From the options, option D is the correct answer. Okay, next question. If the frequency changes from 50 Hz to 1000 Hz, okay, keeping voltage is constant, the inductive reactance of the coil connected to supply is, okay, inductive reactance. Okay, if frequency changes from 50 Hz to 100 Hz, then inductive reactance will be, okay, we have inductive reactance XL is equal to 2 pi FL. Here frequency is varying. Okay, XL is directly proportional to frequency. Okay, if frequency is changed from 50 Hz to 100 Hz, okay, XL2 by XL1 is equal to F2 by F1. Okay, XL2 is equal to frequency F2 is equal to 100 by 50 into XL2. Okay, 51 52 ja XL2, this is XL1. XL2 is equal to 2 times XL1. Okay, if frequency changed from 50 Hz to 100 Hz, the inductive reactance changed from XL2 to XL1. Okay, it will become double means option B is the correct answer. Okay, next question. In a delta phase system, the line voltage is, okay, dash times of E phase. Okay, delta, we have two connections, one is delta connection and one more is star connection. We can discuss one by one. This is star connection. Okay, this is star connection. Okay, star connection. Here this is IL, line current. Okay, this is phase current, I phase. Here same line current will flow through the phase. Here IL is equal to I phase in star connection. Alage here VL, this is V phase, this is V phase, VL, this is VL. Okay, VL, here VL is equal to root 3 times of V phase. Okay, root 3 times of V phase. Okay, in star connection, line current and phase currents are equal, but phase line voltage is equal to root 3 times of phase voltage. But in delta connection, okay, let us say this is phase current. Okay, this is line current. Okay, line current is equal to root 3 times of phase current. Okay, this is line voltage VL, this is phase voltage V phase. Okay, V phase. Okay, here line voltage is equal to phase voltage. Okay, in delta connection, line voltage is equal to phase voltage, but line current is equal to root 3 times of phase current. In the question they are asking line voltage is equal to phase voltage, means 1 will come. Okay, next question. What is the expansion of RCCB? Okay, RCCB. Okay, RCCB means residual current circuit breaker. Residual current circuit breaker. Okay, from the options, option C is the correct answer. Okay, what is the full form of ELCB. Okay, what is the full form of ELCB? Okay, you can comment in comment box. Comment your answer in comment box. Okay, next question. What is the fusing factor of rewirable fuse? Okay, what is the fusing factor of rewirable fuse? Fusing factor is equal to fusing current by rated current. Okay, this factor will be, fusing factor will be always greater than 1. Okay, this is 1.4 for rewirable fuse. Okay, from the options, option B is the correct answer. Okay, next question. What is the international color code for international current color code for identifying earth wire? Okay, black, red, blue, green. Okay, earth wire color vachesi green color. Okay, we have color code RYB. Okay, RYB, red, yellow, blue is the color code for phase wires. Alage green color is for ground wire or earth wire. Okay, alage black wire is for neutral wire. Okay, next question. Which of the following frequency has longest time period? Okay, which of the following frequency has longest time period? Okay, time period, what is time period? Time period is equal to 1 by frequency. In the question they are asking long period. Okay, long period, మనకి time period long కావాలంటే మనకి frequency అనేది low ఉండాలి. Okay, if frequency is low, the time period is very high. Okay, because they are inversely proportional to each other. Okay, frequency చాలా తక్కువ ఉండాలి. Okay, from the options, very low frequency is 1 Hz. Okay, 1 Hz is having highest time period. Okay, option A is the correct answer. Okay, next question. According to I rules, high voltage limit is, okay, high voltage limit. Okay, మనకి different types of voltage ఉంటాయి. Low voltage, medium voltage, high voltage, extra high voltage and ultra high voltage. Okay, low voltage వచ్చేసి up to 250 volts, medium voltage వచ్చేసి up to 650 volts, high voltage వచ్చేసి 11 kV to 33 kV. అలాగే మనకి extra high voltage వచ్చేసి 66 kV, 132 kV and 220 kV. Okay, అలాగే ultra high voltage వచ్చేసి 400 kV and 762 kV and above. Okay, in the question they are asking about high voltage is up to 33 kV only, does not exceed 33 kV. Okay, 33,000 volts. From the options, option A is the correct answer. Okay, next question. What is the maximum temperature that class B insulation withstand? Okay, class B insulation can withstand up to. Okay, we have different types of insulations. Class, this is class and limit. Okay, class Y, A, E, B, F, H, C. Okay, Y limit is up to 90. Okay, అలాగే class A limit వచ్చేసి up to 105 degree Celsius. Okay, అలాగే E వచ్చేసి 120 degree Celsius, B వచ్చేసి up to 130 degree Celsius, F వచ్చేసి up to 155 degree Celsius, H వచ్చేసి up to 180 degree Celsius, అలాగే C వచ్చేసి greater than 180 degree Celsius. Okay, from the options they are asking class B వచ్చేసి మనకి up to 130 degree Celsius, cannot exceed 130 degree Celsius. Option B is the correct answer. Okay, next question. An insulating material should have, okay, insulating material ఒక ప్రాపర్టీస్ అనేవి low dielectric strength ఉండాలా, or low cost, high dielectric strength, high mechanical strength, or high cost and high dielectric strength or low mechanical strength. Okay, high cost అనేది ఉండకూడదు, high cost అనేది one of the disadvantage. Okay, option D, C is the correct answer. అలాగే low mechanical strength అనేది ఎప్పుడైనా మనకి high ఉండాలి. Okay, option D also wrong. Okay, dielectric strength కూడా మనకి high ఉండాలి, low ఉండకూడదు. Okay, option B is the correct answer. Low cost, high dielectric strength, and high mechanical strength. Okay, option B is the correct answer. Okay, next question. The dielectric material is a, okay, dielectric material is a good conductor or insulator or resistor or capacitor. Dielectric material, మన dielectric material వచ్చేసి capacitance, two plates మధ్యలో యూజ్ చేసే మెటీరియల్ వచ్చేసి dielectric material. Okay, this is dielectric material. Dielectric material. Okay, we can also call dielectric material is one of the insulator. One of the insulator. Okay, from the options, option B is the correct answer. Okay, dielectric material is insulator. Okay, next question. The insulation resistance of a cable is specified by the manufacturer is 250 megawatts per kilometer. Okay, per kilometer 250 megawatts. Okay, the resistance of the insulation of 250 meters length is, okay, మనకి 1 కిలోమీటర్కి 250 మెగా ఓమ్స్ ఉన్నప్పుడు 200 మీటర్స్కి ఎంత రెసిస్టెన్స్ ఉంటుంది. ఓకే, మనకి రెసిస్టెన్స్లా, ఓకే, రెసిస్టెన్స్ ఆఫ్ కండక్టర్, ఓకే, రెసిస్టెన్స్ ఆఫ్ కండక్టర్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు లెంత్. అలాగే రెసిస్టెన్స్ ఆఫ్ ఇన్సులేషన్ ఈజ్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు లెంత్. ఓకే, రెసిస్టెన్స్ ఆఫ్ కండక్టర్ అనేది డైరెక్ట్లీ ప్రపోర్షనల్ టు లెంత్, అలాగే రెసిస్టెన్స్ ఆఫ్ ఇన్సులేటర్ ఈజ్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు లెంత్. హియర్ ఇన్సులేషన్ రెసిస్టెన్స్ ఈజ్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు లెంత్. ఓకే, వీ కెన్ ఆల్సో రైట్ R2 by R1 is equal to L1 by L2. Okay, R2 we have to find. Okay, L1 is 1 kilometer, means 1000 meters, by L2 is 200 meters into R1 is 250 mega ohms, 250 mega ohms. Okay, 200 1 ja 200, 5 ja 5 into 25 is equal to 125 is equal to 1250 mega ohms, 1250 mega ohms. Okay, from the options, option C is the correct answer. Okay, next question. What is the life of underground cable? Okay, underground cable life వచ్చేసి 40 to 50 years. Okay, next question. Which conducting material is used for electrical wires and cables? Okay, electrical wires and cables కి మనం యూజ్ చేసే మెటీరియల్ వచ్చేసి కాపర్ ఆర్ అల్యూమినియం. Okay, కాపర్ ఆర్ అల్యూమినియం. From the options, option B is the correct answer. Okay, thank you so much.